Question 13. Given that polynomial is x power of 2n minus p plus 1 x squared plus p, where your n and p are positive integers, for the question A, show that x minus 1 is a factor for this polynomial for any value of p. When x minus 1 is a factor, from here we can get x is equals to 1. So we need to show that this x equals to 1 is a factor. We will substitute value of 1 into the polynomial so that we get 1 power of 2n minus p plus 1 and then 1 power of 2 plus p. So for 1 power to anything, we will still get back to the value of 1. And then 1 square, we expand with p plus 1, we will get negative p minus 1 plus p. Finally, we get 0. When we substitute a value of x and to the polynomial and we get 0, which means that we don't have any remainder. So when we don't have any remainder, which means that this x minus 1 is a factor for our px for any value of p. For question B, it said when p equals to 4, we need to find what's the value of n so that x minus 2 is a factor. So when a factor, you put a bracket like this. X minus 2 is a factor for this polynomial. Therefore, we substitute p equals to 4 into our polynomial. So 4 plus 1, it will become 5x squared plus 4. Now we use factor theorem. So factor theorem, from the x minus 2, we will see x will be equals to 2. From factor theorem, p2 will equals to 0. Remember to write our factor theorem correctly. So when it is a factor, we will equals to 0. Now we will substitute 2 into our polynomial. So 2 to n minus 5 times 2 squared plus 4 is equals to 0. So from this equation, we are going to simplify and get the value of n. From question B, we get our n equals to 2. Now we are going to answer for question C, factorize this polynomial completely. We will substitute n as 2, it will become x power of 4. You can refer back to the question A. It mentioned that x minus 1 is a factor for this polynomial. For question B, it mentioned x minus 2 is a factor for this polynomial also. Therefore, we already given 2 factors. So these 2 factors will become our divisor. In order to find another 2 factors, so this divisor will equals to x squared minus 3x plus 2. So I will divide these 2 factors in order to get another 2 factors. For our polynomial x to the power of 4, remember to insert 0x cubed and 0x plus 4 After we finding our divisor, we will take our polynomial to divide with these two factors in order to get another two factors. So now we will start our long division. We will get x squared times x squared to get x to the power of 4. Then we expand for the rest. Minus to get the remainder. Then to get out of 3x cubed, I will times 3x to the x squared. And then expand for the rest. Then minus to find the remainder. Finally, to get out of 2x squared, I will times 2 to the x squared and expand for the rest plus 4. So notice that our long division will not have any remainder because this divisor is a factor from the polynomial. So now we can rewrite our polynomial equals to x minus 1, x minus 2, where this is our divisor, times with its quotient, and then plus no remainder, so 0. Now we're going to see, is it this x squared plus 3x plus 2 can be factorized. So now we already complete factorize for this polynomial power of 4.